Hey guys, it's me again, Miss Cram, and today we are talking about exponential growth. All right, so exponential growth has been in the news a lot lately, although you maybe haven't heard it called that with coronavirus, right? See how there's graphs sometimes where it just goes straight up, right? That drastic increase is a characteristic of exponential growth. All right, so growth, sorry, growth always increases. There is something called exponential decay that we're going to get to tomorrow. And it's very similar to this, except we'll have a subtract. We'll be subtracting a rate instead of adding it. Okay, so in this equation, your A is your initial amount. So in this example below, if you read it, it's talking about someone that's investing 400 bucks. They just put their 1,400 bucks into a bank. That's their initial amount. Okay. The one really is 100% of that initial amount. So it's 100% of the initial amount plus whatever percentage it's increasing. Okay. Now, this whole thing, right? This whole thing, if you add it together, or tomorrow when we get to decay and you're subtracting, that is your common ratio. Okay, so we've worked with common ratios where if you take any term in a sequence, a geometric sequence, and divide it by the term in front, that gives you the common ratio. And let's see. So, right. All right. So we have this investment of 1,400 bucks. That's why it's right here. And then it's increasing. That is a key word to tell you exponential growth. The other kind of tip off that this is exponential is that it's a percentage, right? So exponents, right? They have a rate, they have a percentage that they're going up or down. Okay, so I have 100% of 1,400, right? That this one is like 100%. And you should have watched the video before this one where you converted 9%, which literally means 9 per is divided. Cent is 100, like 100 pennies. That's why they're called cents. And you need 100 of them to make a dollar. So that would give you 0.09 cents, right? And this decimal version is representing that 9%. All right, so your rate here is 9% or 0.09. And your common ratio is 1.09. So if I were to be making a table, right, and let's say my initial, so it hasn't even been in there like a day, my initial amount that I put in the bank is 1,400 bucks, right? To find out after like 1 year, I would do 1,400 times 1.09. Okay, and I would keep building my table out like that. Okay. All right, so that is all I want to say on that example. So while I'm doing this, if you have not already gone over the example on the next slide, please do that before I get to it. Okay. All right, now let's go to the next slide. Oops, not Q&A. Nope. Okay. So this one, if you went over it, you should have noted that Navarra's was an arithmetic sequence. Here, she keeps going, her investment keeps going up by $100. So every month it's plus 100, plus 100, plus 100, plus 100. So that repeated addition is arithmetic. Okay. And we're not going to go over this too much, but if you want to do the equation, you should get y equals 1,000 plus 100. And here I'm adding 100 to my initial amount 0 times. Then I would have 1,000 plus 100. Here I'd have 1,000 plus 200, right? So all the hundreds that you're adding, they match with your x values. So I can just put 100x. All right. Okay, so, but that's arithmetic. That's not where I want to spend all of our time. I want to spend all of our time right here with Shin Young's money. All right. So here she is going from 1,000 to 1,100. Oh, okay, same amount there. To 1,210, a little bit more here, to 1,330. So I'm not just adding 100. So to find my my common ratio, I'm going to take any of these terms, right? So let me pick 12, 10, and I'm always dividing by the number in front of it. So 1,100. Okay, and I'm going to do that on my calculator, which is my phone. Let's be real here. Okay, so I have 1210 divided by 1,100. Okay, and I get 1.1. 1.1. So this, again, my common ratio, if I'm doing the same formula that they had on the other slide, just the one that we just did, I would get y equals, right? My initial amount is this 1,000 bucks. 1,000, 1, 2, 3, right? And here it's 1.1. So remember, the first one is 100% of that 1,000, and I'm going to add something to it to get this common ratio of 1.1, right? So I'm going to be adding plus 0.10 or 10%. This is going up 10% each year. It's right here. Okay. And then I have the x. Okay. I like putting x. They like putting t for time, so you can really do either. So after 10 years, you can replace this x with a 10. So that would be 1,000. Oh, this takes so long to write. Times, I could just write it 1.1, right? That's the same thing. 1 plus 0.10 or 10% is 1.1. And I can just replace this with a 10. I don't even know if I have an exponent on my calculator. Let's see. Okay. I don't think so. I'm just using my phone. So put that in your calculator if you can for all of these, right? 1,000. And I think when you do the Desmos, then it will do the calculation for you. All right. And then I put in 20 for the exponent here. That should probably be a little smaller than what I made it. Okay. Remember, exponents, sometimes it's easy just to write them on the side, but you really got to write them like they're sitting on the shoulder. Okay. And then here, 1,000. And even as slow as I'm going now, this is a ton faster than doing times 1.1, times 1.1, times 1.1, times 1.1, 50 times, right? Okay. All right. So I will let you guys do that. Maybe me or Miss Mystery will let you know today what these are. And that is it for right now.